Hello, geometry scholars. Today we're going to be doing skill 5.3, which is on triangle congruence criteria. We are not writing complete proofs yet, but today we're going to be kind of thinking about what are the minimal pieces of evidence that we need in order to prove that a triangle is congruent. And I am going to push the evidence thinking a little bit on some of the examples today. But the main focus is just going to be thinking about what is the general reason for why two triangles are congruent. One thing that I do want you to do is use the rulers at your desk and kind of engage in a design challenge. So your goal is to create two perfectly congruent triangles using the ruler. And if you're able to successfully do that, I'd like you to kind of write your thought process on how you did that as well. I have a few review problems to go through. These are some good warm-ups to make sure that you're on the right track with evidence matching from the diagrams. One thing that you'll be doing today are the quick notes. And I'm not going to show you here the filled in quick notes. But one thing I am going to kind of tell you and advise you is that things like the S, hi Tipper, this is my cat Tipper over here. But things like the S, they stand for sides, and the A stands for angles. And one thing that you'll kind of learn is that if two triangles have the same exact matching sides, then that's enough to show that they are congruent to each other. So like this would be called side, side, side. Or like if I have a situation where I have a side that's congruent to another side, another pair of sides that are congruent, and then an angle between them, that spells S A S. So I do like you to kind of fill in those quick notes just to make sure that you have the five main triangle congruence theorems. We also have a few things that spell out things that are not triangle congruence theorems. So one case, for instance, is the side angle, or if you kind of spell that backwards, it kind of spells a inappropriate word, but here's a side and here's a side, and then maybe I have an angle like that. But it turns out that if I'm actually going to draw that same side, I don't need, if I kind of look at the next side, it doesn't like predetermine what angle I draw it at. So I could like change the angle and then have that third angle not between them. And I don't even get a triangle. So SSA is inappropriate. And then angle is inappropriate as well for angle, because I could have like an equilateral, equiangular triangle. And these have all the angles at 60 degrees, but I could have like different sizes of equilateral triangles. I do want to walk through a few examples. I think the problems in this skill are pretty straightforward. So they're pretty much, are the triangles congruent or not, and why? Um, so I kind of just made like the same template and format, and this will get you mastering the triangle congruence theorems. And if you actually take time to put the evidence in, you'll even see that the transition to proofs next class will feel easier. So what I do is I just kind of mark the diagram. I kind of think to myself, side or angle, that's an angle. That's an angle, and that's a side. So it spells A, S. And that is one of the ones that is a appropriate word. So it is yes. And if I want to get really fancy, I can kind of match the evidence. So I could say that angle G and angle B, since they have two notches, are congruent to each other. I could also say that angle C and angle E are congruent to each other. And then I have the sides and the bottom. So I could say that CD and EH are congruent to each other. And believe it or not, next class, we'll kind of introduce you to Delta Maths flowcharts, and you can actually put these pieces of evidence in what we call a formal proof. So we're going to kind of learn about that in about a class or two. The one on the right is kind of a less basic one. And on the surface, it only looks like we only have two pieces of evidence. So I got an angle, and then I have a side that's kind of marked. But we do want to kind of pay attention to the middle in here, because if we kind of look at the middle, and let me just kind of highlight this a little bit more. I have two angles in the center that are congruent. Think for a second before I say it. It's a vocab word that's on your final exam. Vertical angles. And you could actually use vertical angles to kind of get you that third piece of evidence. And that's going to get me a angle. So if we're kind of asking ourselves, are we congruent or not? The answer to that is yes. We are congruent because it spells A, S, A. They kind of travel around a triangle. We're going to say ASA. And if we want to get fancy, we can put the evidence in there as well. So I could say that angle O is congruent to angle X. And let's see, the point in the middle, I believe, is point M. So I could say, let me just make sure. I'm just going to erase it a little bit. Yeah, it is M. So I'm going to actually say that side OM is congruent to side XM. So both of these things are kind of given in the picture. And then I can use those vertical angles in the center. And when you have two angles that share the same point, make sure you're naming them with the 3 points. So I will say that angle PMD is congruent to angle XMQ. And to kind of ease us into the transition of writing proofs and a skill or two down the road, if I just kind of say that vertical angles are congruent, that's enough to show why the triangles are congruent to each other. So in the next two classes, we're going to learn about ways that you can like put this into a flow chart or a statement and reason chart and actually be very successful in writing your own proofs. So what I like you to kind of be doing the rest of the time is try some of these you try problems. So here they are. Um, we'll get you exposed to a wide variety of triangle congruence theorems. Delta Math will kind of start you with the basic ones like number one or two with the standalone triangles. And then I have a few teacher created ones that are kind of like our medium and more difficult ones that have shared sides or vertical angles. And if you're in honors, I might actually start you with some formal proofs on the Delta Math assignment. So it's just kind of transitioning those evidence pieces into the flowchart format. So as always, please reach out if you have any questions, and thank you very much.